No matter how tempted you are, do I ever want you to graph a function in the calculator and then just blindly copy the graph onto your page? No, there's no value in it. I'm aware your calculators can graph. I don't care. I need to know if you can. So the calculator's a tool, right, to help us do it. They're not going to do the problems for us. Eventually they will, because there's some problems that we just use them with, but it's not with graphing logs, especially for right now. So here's where we're at. Our last topic, and I'm just trying to, I do need to see them for just a second, just so I can get the bullet points and stuff. Okay, we talked about the natural base, right? E. What's E approximately? 2.7818, blah, blah, blah. Now, as we look at our functions, remember our exponential functions, we looked at this a little bit, we alluded to it. Our exponential functions are injective, meaning what? They're one-to-one, and I liked what you said as well, Wisha. Their inverses exist. Now, we spoke last week about logs and exponentials, and just to see, what's the inverse of an exponential? The log. The logarithm is its inverse. They undo each other, and there's going to be some awesome properties that we use with those. So here's what we're going to jump in with today. We talked about graphing exponentials, and it's not too bad. We're going to jump in today to graphing logarithms instead. Now, not a chance that I'm going to write logarithm. We're just going to graph logs. Okay. If you guys over there want a little bit more vision, just so you don't have to strain your eyes, I'll get that one on too. Now, it turns out that when we graph these, we are going to follow essentially the exact same, almost the exact same thing that we did with the exponentials. When I graph an exponential, and remember pink is for think here, if I graph a to the whatever, x here, I want this value to be what when I'm plugging it in and actually getting my points? What did we want the exponent to be equal to? Three nice numbers. -1, 0, and 1. Now, if we can remember that that's what we do, and it might be x, it might be something uglier, right? And we have to do a little bit of scratch work. It's okay. If we can make our exponent these three things, it's really easy to plot those points. Coincidentally, graphing logs is going to be about the same. So let's try to think one out here, just in general. Without having any of the standard rules starting, let's just do an example right off the bat, and then we'll come together and say, well, here's how we really do this. Okay, so we'll sketch, and these are going to be pretty specific here, but let's get a nice log function to start with. I want us to sketch the graph of a function f of x, and there's not going to be any changes to it. We'll just make it nice and easy. Log base 2 or 3? 2 of x. Now, to graph this thing, it's intimidating to a lot of people. First thing that I need to be like really clear with, Matilda, what is the base of this log? The base is 2. Now, when we graph these, there's a few different ways that one can think about it. Here's what I want us to think. What's the argument? And we're just going to refine this to make sure that we have it. Here's my base, and I'm fine with that. This is base 2. What's the argument of this log? Okay. This here is the argument. Love it. Now, I'm going to do some writing over here just to think out stuff. What could I possibly put in here that is easy to calculate? 1. Why is that easy? So what is log base 2 of 1? 0. Why 0? Because what's my base? 2, and I'm bringing it to what power on this one? 0. And that's 1. 2 to the 0 is 1. This is why it works. It works really nicely. Okay, can you tell me another one that you think is really easy? Log base 2 of, and we'll make a table and stuff. This is just nice motivation to see. It's so much easier than you might think. Any other easy number? 2? Now, anybody other than Krina? Not that I don't want to hear your wonderful answers, but I want to make sure that we spread the love. Abijah, how do I think of this question? Like, do you feel logs are stressful? Okay. When I ask this question, what's our base? And I'm wondering, 2 to what power gives me 2 again? because, and again, here's our 3 dots for this wonderful because, 2 to the 1 is 2. Everybody cool there? Again, there's one more really easy value that's not 4. Other than 4, 1/2 is perfect. That's also a really easy one, Red, just so you know. 2 to any power is also easy. This one is the one that I really want. Why do I want this? Oh my gosh, notice what's about to happen. 0, 1, and -1 are the numbers that we want on our exponentials, right? They're easy to graph. Before we get there, 2 to what power gives me 1/2? -1. Now, check it out. This is the weirdest part, and we're going to summarize and put this all together when we graph this. Notice what happens. On this function, we pick x values to make my exponent these 3 numbers. In these ones, these are all the outputs, right? They're my y's this time. But remind me, if this hand is all of my domain and this is the range, when I look at inverses, what happens with these? They literally just swap places. And if you're comfortable with seeing -1, 0, and 1 as your exponent, then we need to pick x values that make this happen. Now, in more generalized sense, we pretty much just did our whole table. We're going to summarize this real quick, and we'll remake this table much more efficiently. When graphing, and this, I'm going to make this super important statement. When graphing, log, and we're going to write the ugly version of it. When graphing something of the form y equals a times log base b of cx minus h plus k, which we'll pause here just to really appreciate that while this looks terrible, it ain't. Thank you, by the way. I could already see in your eyes you're saying good catch. This looks worse, I think. Everybody agree with that? Is this really the same thing? What's A here, the number in front of it? Okay, so it's done, taken care of. What's my base B? Already taken care of. What's C, the coefficient on X? 1. I'm subtracting what from it right here? So careful, not 2. 0. And then what's the plus K out here? These are in the exact same form. I just get a bunch of 1s and 0s, coincidentally in this one. Okay, if you can look at a log, this, and I think everybody can do this. We're going to try on the count of 3. All I'm going to ask is on the count of 3 to tell me the base of this ugly, terrible expression. On the count of 3, what is the base? 1, 2, 4. Oh, got him. Got him. That wasn't 3. 1, 2, 3. It's B. I kind of killed our momentum there. Do you guys agree it's all B? Okay, check it out. When graphing anything like this, no matter how ugly it looks, here's the deal. We want to pick x values. Pick x values that make the argument this time. Whoops. The argument. And we're going to try to pick this out here. Equal to, and there's going to be 3 values. Now, you're going to be tempted to answer this incorrectly. The natural choice is for you guys to want to say -1, 0, and 1. But it's not. Check it out. This is not, okay, so in this case it's weird. This one, is this 0, 1, or -1? But that's my argument. Is there a connection between this number and this number in these 3? Do you agree that no matter what base this is, if I say log base 7 of 1, it's still 0? So we get 3 choices every single time. Now, it depends on what value of b we actually get, or the argument rather. But check it out. We just want our argument every single time to be equal to b, whatever the base is. And I'll even write base. We want to pick an x value that makes our argument the base, which is exactly what we did right here. We made our argument the same as the base. Done. What else did we make it? We wanted to make it, how would you explain this number with regard to the base? So good. I'll cool with 1 over base. And there's one more choice. Here's b. Here's 1 over the base. And the other one just stands alone, unique. It's 1. Now, what this ultimately does for us, if we do this every single time, there will never be a situation where at least the log part of our graph is simply going to be 1, 0, and -1. We'll always get the nice values out. Okay, 2 more little things, and maybe we won't fully graph this one, and we'll do a better, more exciting one here in just a second. But I do want to make a couple comments or questions for you guys. I want you to try to figure out the following. Okay, this one. I'm going to put caution or cuidado. Dolan, do you understand that? What's it mean? Careful, caution, right? We're just doing a little bit of Spanish here. Cool. I don't know how to say it in Tagalog. Hook it up. Uh-oh. Somebody knows how to say careful or caution. Tagalog speakers, careful. How do I say it? Okay, we're looking for careful. All right, give it a second. I got you. ABC. Careful. Holy cow. So many words in here. Weird how that works. Mein Gott. Mein Gott. Mein Gott. No, just as Mein Gott. They do not say Ingat. Ma Ingat. Okay, I just can't read. I was trying to use Ma Ingat. Yep, okay. The stressing is different. Okay, regardless of the language, caution. Okay, check it out. I want you to try this forward for me. Real quickly, try to evaluate log base 2 of -1. I'm going to give you guys a moment. Our big warning. The vertical asymptote happens when x is equal to, and it might be an inequality when we get there, but we'll have to work on specific things. When x is equal to value that makes argument 0. Okay, we cannot have the argument of a log be 0. And in fact, less than 0. Less than or equal to is probably the better thing to say. And it will shake out then as an inequality, but we'll deal with it. Okay. We talked a lot about this problem. Do you want to actually build the table for this specific log and then graph it? Or do you want to build up a little bit different one? Let's do this one since we already have it written. Cool. Okay, so I'm going to pretend like we didn't already do all this scratch work, and only using the stuff here, we're going to try to graph this. So I'm going to make my table, and you guys are going to make the table. Once we do this by hand a few times, do I care if you use your calculator? No, in fact, I'll even show you how to do log base, who cares, on your calculator. But I don't really care if your calculator can do it right now again. Okay, so we're going to use 3 columns. X, log base 2 of x. And would you prefer f of x or y? How come? Okay. You can write y. I'm going to write f. Purely subjective. All right. So here we are. I've erased all of the scratch work that we had a second ago that we'd already thought out. Davian, what is the base of our log that we're graphing? 2. I want my argument, which, Abijah, what is the argument this time? X. I want to pick values of x that make my argument 3 things. What's one of those things? Not -1. Careful, you're already getting 1. Did you say negative the first time or did I mishear? Okay, so let's make it 1. Now, there's no scratch work needed here. It's already all set up. It's as simple of an argument as we can get. What value of x should I pick for this argument to make it be a 1 right here? Done. It's a 1. If I do this, and we do our 3 columns, we get log base 2, and I'm going to just copy this so I can paste it onto the next one. I can't see it if it's on the black one. Whoop, that did way more than I was expecting. Do it. Cool. Okay, if I do this, I get log base 2 of what does my argument become? 1. And again, help me out here because this is where we have to switch our thinking, right? We're just doing it backward from the exponentials. 2, and this is up to you if you want to write it, 2 to what power equals 1? 0. So log base 2 of 1 is 0. Check it out. The point 10 is on my graph. Piece of cake. Lay, what's something else I want to make? What's something else I want to make my argument? I've already made it 1. Check. Don't want it to be 0. Yep. You can either choose the base or 1 over the base. Okay, so let's make it 2. And now in this case, there's no scratch work because it's just x. If there was something uglier, we might have a little bit of scratch work on the side. I can just pick a 2 here. 2. This becomes log base 2 of 2. It's nice. Addison, you weren't here last class, and I forgot to post a video, so you're going to just go right into the deep end. A little swimming pun for you. Read this expression to me real quick. Of. Okay, so you may be rusty on this. 2 to what power gives me 2? Boom. If you can tell me that, you can do the log. That means we just got a second point out. 2, 1 is another point on my graph. One more, Karina, what value of x would you have me plug in here? 1/2. Now, again, these will change depending on how ugly our argument is, but if it's just x, it's pretty chill. Log base 2 of 1/2. 2 to what power gives me 1/2? -1. Boom. I have 3 points. Before I graph it, because if we don't make this comment, I have a sneaking suspicion that you're going to destroy the graph and I'm going to steal points from you. There is always, always some vertical line that I'll never touch, no matter how close I get to it. What am I referring to? The asymptote. Okay. I hate the way you said it, by the way. But, yep. So for anybody that doesn't recall, and really it's for you too, my student teacher hated me, and whatever, that's fine. But she said asymptote, and I don't know why, and it's stuck in my head. Can't even remember her name at this point, but I remember that she said asymptote. What is the argument this time? Okay, this is going to seem silly. What value of x makes my argument, which is just x, equal to 0? So 0 is like the only choice, right? This is my vertical asymptote. It's at x equals 0. Okay. From these 3 points, and only these 3 points, I feel pretty good about getting this thing graphed nicely. First off, which quadrants do I need to show? 1 and 4. If you want to show all 4 of them, more power to you, but I really only need this. Here's x and here's y. Fantastic. This one's always hard to add. I'm going to use a green, I lied, I'll use a pink line, and I'm going to do it here. What is this indicating to me? There's an asymptote that I don't touch. Now, as far as picking the scale, I need to be able to see 1/2. So I have graph paper handy. Here's 1, here's 2, and I don't have to go any further than that. What about in the y direction? You want me to pick the same scale, bigger? The same, sure. So there's 1, and here's -1. Okay, check it out. Easy. 1, 0 is right here. Now, I do want to look at something else here in just a minute. We're going to see a connection back to the exponential stuff. Okay, 2, 1. I'll go from the origin to where x is 2 and all the way up to 1. There's that point. And the last one I did in purple, which I kind of regret at this point, but we get 1/2, -1. Is there a curve that exists such that it will pass through all 3 of these points? Yeah, and I think it's obvious. It's obviously this one, right? Why? This guy doesn't pay attention to asymptotes. All right. Can you feel my blood pressure increasing when I say it? Because I sure can. All right. Here's our wonderful log graph. Okay. Here's something awesome that I want to show you guys that I know we've talked about it. It might not fully click, though, if we don't explicitly state this stuff. I'm going to draw, for arbitrary reason maybe, this line also, and I'm just trying to pick a different color. I just drew the line for which function? All right, love it. Now, what is the base of this log again? And I just want to double check something. The inverse of log base 2 of x is the exponential with base 2 to the x. Now, I'm not going to build a whole table here, but I do want to just really make sure that this is super clear. In this situation, I would pick 0, 1, and -1. So check this out. What's 2 to the 0? 1. Okay. And let's see, what's 2 to the 1? So 2 to the 1 is 2. And that would be like up here, right? 1, 2. And 2 to the -1 is 1/2. Notice here the connection. And I'm not going to be perfect with this. I'm going to dash this one. Is there a connection between these graphs? Oh my gosh, it's like they did exactly what every inverse ever should do and does do, and it's just reflected over the line y equals x. This log stuff, you guys graphed them last year. It's natural for the first time that you graph a log to think yuck and they suck. Are these super challenging? Let's try a harder one. And by let's, I mean I want you guys to try a harder one. So let's do it. Questions before you get to experience a little taste of freedom here. Okay. I don't know. I was just born that cool. That's a great question, though, Red. All right. Let's knock it out. You guys are going to help me make one up here on Bravo. I don't know what we're graphing. We'll call it g of x equals, what's your, let's get wild with it. 2 times log base not 2. You know what? I'm not even going to write a base. Log of 2x plus 1 minus 3. There is a base. I just didn't write it because it's so common. You might have to look at the page for common. It's 10. Cool. All right. You guys get 4 wonderful minutes. I'm going to be walking around to do 2 things, to get my steps and to make myself available. Remember, while I'm doing this, I want you to be using the shape of your mouth and the rate at which you are exhaling air to communicate ideas with your neighbors. Cool. Do it to it. 4-minute timer starting as soon as I get to it. Vi. How much money you got? Okay. If you're going to pop, yes. If you can wait, cool. Like, it's your call. I started taking points again. Just, it's not an empty threat. Probably soon, yeah. Okay. Realistically, probably not soon. I changed my mind. You should just go if you're going to go. I don't know that we'll have homework. As we look at it, I'm going to immediately jump in with the scratchwork side of stuff. So, remind me real quick, 2 things we have to be able to see. And once you identify these, step 1, what's the base? 10. What is the argument, which I will henceforth just say arg? 2x plus 1. So here's all of our scratch work, and I'm going to do 3 times. We're going to make 2x plus 1 equal to one of the 3. Don't care. 1. We'll start with that. Okay. I think it's when x is 0. Okay. Now, here's the important part that people often overlook. If we need to do the math to solve it, like I'm good with that. -1, -1, 2x equals 0, divide by 2, and x equals 0, right? What I want you to get in the habit of doing, what this means is I don't have to, when I plug x equals 0 in again, I don't have to recalculate everything. This is the x that made my argument 1. So as soon as I get to my table and I write that first part, immediately I'm just going to replace my argument with a 1 once I pick x as 0. Like, we don't have to think about it twice. Should I draw the table so that that's clearer what I just said? Okay, because everybody gets hung up on this. So we're going to do x. We'll do our function 2 log of 2x plus 1 minus 3 and the y or the f of x. Now, your scratch work, some of it's going to be done like mentally, and that's okay. Some of you will show more. Awesome. I'm good with it. But check this out. What was the first x value that we just found? So I don't even have to think. I'm going to put a 0 right here. And when I get into here, I'm not thinking. It's not like I'm doing this fast. I know that 0 was the answer I got when I made my argument. What value? It's already 1. I don't have to go back through and say 2 times 0 is 0 plus. Nope, it's already done for me. Okay, once we get here, do you want to get the y value or do you want to do more scratch work? Okay, so this is 2 times, and we're going to think about this. 10 to what power gives me 1? 0. Because 10 to the 0 is how I get 1. What's 2 times 0? Minus 3. There's my first point. Okay, my second little piece of scratch work, we're going to take 2x plus 1, my argument still, and set it equal to, give me a different number. We made it 1. Can't do 0. It's always base 1 and 1 over the base. What's my base? 10. So when we solve this, and I'm just going to dot, 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 because I trust your guys' algebra, I think I'm going to get 4.5. Or 9/2. But again, check it out. I don't have to do any work. And I wish that I had copied this so it could just come out once. When I get here, and I'm not like thinking, I'm not stalling or anything like that, but I know for a fact at this point in time that if I write a 4.5 here, it's going to make my argument a 10. We just did all the scratch work to get that. I know immediately it's this. I don't have to re-plug in and calculate. It's just automatically going to be 10 because that's what x we got when we set it equal to 10. Okay, now again, same thing, 2 times, and let's think this out. 10 to what power is 10? The 1. Notice, here's the 0 that we talked about. Here's the 1 that we've talked about. And what's 2 times 1? Minus 3? Negative 1. I just got the value 4.5 comma negative 1 on my graph. There's one more little line of scratch work here. We'll use yellow for this one. The last thing I'm going to do is set my argument, which is still 2x plus 1. And we're going to set it equal to what this time? We've made it 1. We've made it 10. 1/10. If you want to use 0.1, do you think I'm cool with it? For sure. Yeah. I'm going to subtract 1, which says 2x equals, do you want me to use decimals since we're going to put it on a graph? Okay, so let's see. 0.1 minus 1 is negative 0.9. And we'll divide it by 2. And x equals negative 0.45. I think. Pretty confident on that. Now, again, I want to really stress just how easy this is. I know for sure now that when I put negative 0.45, it is going to make my argument equal to what number without calculating it? Good. We got that x value when we set our argument equal to 1/10. When I pick this x, it makes it 1/10. So here we go. 2 times, log of 1/10. How do I even think about that? Ten to what is 1/10? Negative 1. So what's 2 times negative 1? Minus 3? Negative 5. We now have 3 wonderful points that I'm pretty confident that we can graph and graph it well. Okay, when we go through this, where were you guys getting goofed up? Okay, I heard 2 different things. With I'm sorry, can you repeat that, Lay? Always the hardest part, for sure. People naturally want to pick 0 because that's what we do with the exponentials. And Christina, what was yours? Deal. If you, and that's fair. I would always begin by identify the base in the argument. Always. And then it's that same thing. We wrote it in the steps a second ago. Always argument equal to 3 things. 1, the base, and 1 over the base. If you do that every time, you're always going to get 0, 1, and negative 1 when you evaluate the log, and it's easy to do. Okay, now to graph this thing, all we need is these points. Is there a vertical asymptote anywhere? And we're going to do the scratch work to this. We set our argument 2x plus 1 equal to what number? 0. It can't be 0. This is going to give us our asymptote. And help me solve. What would you do? Minus 1 and divide by 2. So there's our asymptote. It's at -1/2. Sweet. Let's graph this thing. So we get, let's see, 0, 5, and -1. So maybe I'll just go like this. And I happen to have graph paper on mine, which is really convenient. So here it is. And let's see, here's 5. And that's a piece of cake. There's -5, 5. Okay. First thing that I typically add is my asymptote, which is right here at -1/2. Can you guys see the scale better than I can? You can see the crosses on here? Okay, they're pretty meh on my screen. Now it's just a matter of plotting 3 points. 0, -3 lives about here. And we'll go ahead and try to color coordinate here. 4.5 looks like it'd be here, and at -1, there. And the only other one is almost at this asymptote, really close to the asymptote, but at -5. Can I draw something that looks kind of like a log through those 3? And I think it will look just like the log. It'll look very similar to the graph that we drew a second ago. Eventually it'll cross, and it'll keep going forever, but we have it. If you can graph an exponential, you can graph a log, and I guarantee it. Some books and some teachers might suggest you graph the exponential first and then the log. I don't think it's worth it. I think that if we just switch our line of thinking here, and as long as we pick nice values to make our argument or our exponent, doesn't matter, we can graph them nicely. Okay, feeling all right here? Anybody feeling not all right with this stuff? Okay, so I'm going to give you guys a pretty chill homework today, just so you guys are aware. And Lay, if you want to go now and then come back, I'm okay with it. Like, I won't take points at this point. Okay. Sweet. All right. We want a super duper long homework, right? What? Okay. Excuse me. All right. I want you guys to do, we'll call this homework 3.2.1. Is that true? Okay. We'll find this on page 218. And you get the privilege of doing problems. 7 through 19 odd. Super chill. It'll give us, make sure, a good foundation to calculate some stuff. Gosh, I better give you one more. 41 is also on there. Cool. All right. 7 through 19 odd and 41. You guys get 5 minutes to start on that. You guys probably noticed there's somebody else in the room today. She's visiting for English as a second language instruction stuff, because obviously we have a lot of ESL and ELL students in our school. Makes sense. Yep, they're just here to observe a variety of teachers, to give feedback, saying here's things that you can change. Cool. All right, do it to it. You guys get 5 minutes to start.